Today we are going to talk about how to experience success on tomorrow's Unit 6 assessment by going over the questions on the Unit 6 review. So you need your review on your desk, you need your phone put away, you need to be paying close attention to how we do these problems. Alright, so we're going to start with number 1. Number 1, the area of rectangle ABCD is represented by the expression 4x squared minus 15x plus 24. The area of rectangle WXYZ is represented by the expression 5x squared plus 27x minus 3. Which expression represents the combined area of the rectangles? In this situation, combined is telling me that I need to add those two expressions together. If you will keep in mind what you know about the order of operations, this little memory trick here could help you out a whole lot in terms of being ready to answer these questions. So, we're going to add these expressions, which means in terms of the exponents, we need to do nothing to the exponent. So I'm going to write my two expressions, 4x squared minus 15x plus 24, 5x squared plus 27x minus 3, and I'm going to combine them. So 4 plus 5 makes 9x squared. Positive 27 and negative 15 makes positive 12x. And 24 minus 3 is 21. All right, press pause on the video for a second and talk with your group about this question, about what you need to do to be successful on tomorrow's test. When the groups have finished talking, then you can press play again. Moving on to number 2. Sue Lynn has 2 gardens in her backyard, one for flowers and one for vegetables. The flower garden has an area that can be represented by the expression 7x squared minus 11x minus 6. The vegetable garden has an area that can be represented by the expression 20x squared minus 7x minus 3. Which expression can be used to represent how much larger the area of the vegetable garden is in comparison to the area of the flower garden? How much larger? That phrase, how much larger, if I think about 9 is how much larger than 5? Well, the answer is 4 because I would do 9 minus 5. So I want to do the same thing here. I want to do the vegetable garden minus the flower garden. So the vegetable garden is 20x squared minus 7x minus 3. Subtract, the flower garden is 7x squared minus 11x minus 6. It has been my experience that kids do better with these problems if they will distribute the subtraction. So we're going to add the opposite, the opposite, the opposite, because subtraction is adding the opposite. And that will keep you from making mistakes with your signs. So now I'm going to find my like terms. 20x squared plus negative 7x squared makes 13x squared. Again, I'm doing nothing because this is a subtraction problem. I'm going to do nothing to the exponents. They are going to stay the same. All right, so then I've got negative 7x and positive 11x. That makes positive 4x. And finally, negative 3 and positive 6 makes positive 3. All right, pause the video. Talk with your group. Resume the video when groups are done with their discussion. Number 3 is all about capacity. Capacity is another word for volume. So you all learned in elementary school that the way you find the volume of a box is you do the length times the width times the height. So that's what we're going to do in this problem. We're going to do the length times the width times the height. All right, so to be successful from here, you need to do length times width first. You may do that with the box. You may do that with foil. That choice is really yours. I'm going to do the box just because that seems like what most people have been choosing as I've been walking around watching you work. So I get 12x squared minus 45x plus 28x minus 105. So here are my like terms. When I combine them, I get minus 17x. I'm adding those two together. So what I have over here now is I have 12x squared minus 17x minus 105 times 1/3 x. All right, so at this point, it's going to be like distributive property. I have to do the 1/3 x times each one of these. If you don't know how to deal with that fraction, you can use your calculator to help you with that. So if I do 12 times 1/3, I get 4. X squared times x makes x cubed. Then I'm going to have 17 times 1/3. That turns out to be a weird decimal, so I'm just going to write 17 over 3. On your test tomorrow, it comes out a little nicer than that. X times x makes x squared minus 105 divided by 3 is 35x. All right, press pause. Talk with your group, see if anyone has any questions. When all the groups are done, press play again. Number 4, it's all about the area of a triangle. Our formula for area of a triangle is 1/2 times base times height. That's a formula you should know from junior high. So we're going to do 1/2 times 5x plus 4 times 4x plus 5. So I'm going to multiply these two together, and then I'm going to divide everything by 2. (5x times 4x is 20x squared. 4 times 4x is 16x. 5x times 5 is 25x. And 5 times 4 is 20. Here are my like terms. 25x plus 16x makes 41x. So if I'm going to rewrite this, I still have the 1/2. And now I'm going to write 20x squared plus 41x plus 20. All right, so now I need half of each of these. So half of 20 makes 10x squared. Half of 41 is 20.5x. And half of 20 is 10. All right, press pause for discussion. Press play when you are prepared to look at number 5. Number 5 is another area question. You're going to see lots of those on this test. Remember, area is length times width. So I need to multiply my two expressions. Let's just use the box they already made for us. I'm going to write 4x and 2 over here instead of over there. So 3x times 4x makes 12x squared. 4x times 1 is 4x. 3x times 2 is 6x. And 2 times 1 is 2. So these two combine to make 10x. The area is 12x squared plus 10x plus 2. All right, pause for discussion. Number 6 is about volume. Earlier we said volume is length times width times height. When we're talking about a cylinder, we say the volume is the area of the base. Big B is the area of the base. And H is the height. That's the formula you should have used in 7th and 8th grade. So they are telling us the area of the base is this, and the height is this, so we just need to multiply those two things together. This is not a good candidate for using FOIL because we have a trinomial. So I'm going to use the box. I think that's what most of you would choose anyway. If you want to do this using the third grade method, you are welcome to do that. You should get the exact same answer. All right, so 3x times 3x squared makes 9x cubed. 3x times negative 16x makes negative 48x squared. 3 times 5 makes 15x. All right, next row, 2 times 3, 6x squared. 2 times negative 16 makes negative 32x. 2 times 5 makes 10. All right, so now when I'm looking for my like terms, I have two sets. I have these x squareds, and I also have these x's. So I'm going to have to add both of those to get my final answer. So 9x cubed, negative 48 plus 6 is negative 42x squared. Negative 32 plus 15 is negative 17x, and then plus 10. All right, pause for discussion. All right, moving on to number 7. Number 7 flat out tells you what to do right here in the problem. It says to find the length, we're going to do the area divided by the width. They told us the area. They told us the width. So this is where your long division from a couple of days ago is going to come into play. So the area is going to go inside the house. 5x plus 6 is going to go on the outside. All right, so I've got to ask myself, how many times does 5x go into 35x squared? That's like asking yourself, 5x times something makes 35x squared. Well, 5 times 7 would make 35, and x times x would make x squared. So I need to write 7x in that blank, and that means 7x is what I write on the line. Now it's like distributive property. 7x times 5x makes 35x squared. 7x times 6 makes 42x. All right, so after I multiply, my next step is to subtract. So to subtract, I'm going to change my signs and combine. So these add to 0. 102 minus 42 makes 60x plus 72 because I bring that down. So now I'm looking at 5x and 60x. So 5x times something equals 60x. Well, I've already got the x taken care of. 5 goes into 60 12 times. So I'm going to write plus 12 on the line. Distributive property, 60x. 12 times 6 is 72. My next step is to subtract, so I change my signs and combine, and I get 0, so I have no remainder. That means my answer is what I've written up here on the line. All right, pause for discussion. Number 8, which of these are equal to this formula? Well, lots of these have parentheses in them. So what I need to do here is I need to simplify these and see if I can simplify them down to pi RL plus pi R squared. So in this situation, if I've got pi outside these parentheses, this is distributive property. So I'm going to multiply both things by pi. So that's going to make pi times RL plus pi times R squared. Does that match? It does. That one's good. All right, no parentheses here. Let's see. Pi R squared, well, that matches the second part. Plus pi RL, well, that matches the first part. It doesn't matter what order I add in, so this one is also good. All right, number 3. This time I need to distribute pi and R to each thing. So I'm going to have pi R times L plus pi R times R. Is that the same as pi RL? Yeah. Plus, yeah. Pi R squared and pi times R times R. Those are also the same thing. R times R would make R squared, so that one is good. All right, what about this one? I've already got pi RL plus, but what about this squared? Well, if we think about our PEMDAS memory trick, we've got parentheses. We're going to multiply the exponents. So this is pi to the first and r to the first. So this becomes pi to the second, r to the second, and that is not the same as pi r squared. Okay, pause for discussion. Come back to me when you're ready to move on. Number 9. Number 9 says describe the area of the garden with the following lengths and widths. I am going to do a couple of these. I'm not going to do all 4 of them for the sake of time. If you need help with one of them I don't do, you are welcome to come to tutorials Friday morning and I will talk to you about this. To find area, I do length times width. So in each of these cases, I need to be able to do the length times the width. So x times x makes x squared. 21 times x, 21x. Negative 2 times x, and 21 times negative 2 is negative 42. Here are my like terms. 21 minus 2 makes 19, so that's 19x. So the area of this first one is x squared plus 19x minus 42. The biggest thing here is to remember that you're multiplying when you fill in your box, and then when you combine them, you are adding. If you need help with those other 3, please come see me in tutorials. I'd be glad to help you with that. Number 10 is interesting because it's a work backwards problem. They told us the area, and they've gotten us started on the length and the width, but they want us to figure out what else is going on here. So I know 5x squared is going to go right here in my box because it's going to be 5x times x in my expression here. And I know that these two together, the like terms, they're going to have to add up to 17x. And I know that this bottom right-hand box is going to be a 6. So I want to figure out what numbers I could put in this spot and this spot to make that 6 happen. So let's see, things that make 6. 1 times 6 makes 6, and 2 times 3 makes 6. So it's either got to be a 1 and a 6 or a 2 and a 3 in my spots. So let's see here. Let's take a guess. Let's try 1 and 6. I don't know which one goes in which spot. I'm just taking a guess. I'm going to see how it turns out, and if it doesn't turn out right, then I'll take another guess. So 6 times x would make 6x, and 5x times 1 would make 5x. Oh, that adds up to 11, not 17. So it's not 1 and 6. Okay, so let's try something different. If you've got a pencil, you can erase. Obviously, I'm working in pen. So what if I put the 6 here and the 1 here? Would that fix it? 1 times x would make this plain old x. 5 times 6 would make this 30x. So 31x. That's not right either. Okay, I'm going to make another one down here to do the 2 and the 3. Okay, so what if I put the 3 here and the 2 here? 3 times 5 makes 15x. X times 2 makes 2x. Oh, look, that makes 17x. So my length and width must have been 5x plus 2 and x plus 3. All right, pause for discussion. Resume when everyone's ready to move forward. Number 11 is almost the exact same as number 9. You need to be able to box each one of these things or FOIL each one of these things, whatever you prefer. So I'm going to do 1 so that I can talk to you about the fractions. And then I'm going to leave the rest for you to do. If you need help with them, you are welcome in tutorials. Okay, so let's do B. 11x plus half and 11x plus half. All right, so 11 times 11 is 121. X times x is x squared. 11x times a half. What is half of 11? 5.5. Okay. Again, x and 11, 5.5. And then a half times a half. Remember the other day in class we were talking about numerator times numerator and denominator times denominator. So a half times a half is a fourth. So this is going to be 1/4. So the area of B is 121x squared plus 11x plus a fourth. And you'll have a calculator available to you so you can use it to help you with these fraction things if you need to. So don't let that stress you out. All right, I'm going to give you a minute. Compare with your group. See if you got the same thing for each one of them. If you've got questions, try to help each other out. If you can't resolve it, come see me in tutorials on Friday morning. All right, press pause. When you're ready to resume, we will talk about number 12. Number 12, I think, is easiest to think about in this way. If I had a wall and I knew it had, I don't know, 11 rows and 9 columns, how would you find the number of tiles? Well, you'd multiply them and say there would be 99 tiles. Because you do 9 times 11. So we need to do m to the 7th times m to the 8th in this problem. And we know that when we multiply, we need to add our exponents. So this is m to the 15th. All right, press pause if you need to. Discuss that with your group. Come back when you're ready to do number 13. (13) and 14 are probably the ones that kids struggle with the most. So I want to encourage you to take your time and be patient with yourself on these questions. I think that maybe these are the kind of questions where people do better if they do these first. Start with these and then go back and do the others. So if you think that method would help you, then tomorrow on your test, start with number 13, get it out of the way, and then worry about other things. This is another problem where your little memory trick can really help you out if you can't decide what to do. All right, so I'm going to start inside the parentheses and work my way towards the outside. So I'm going to look at 36 over 288. If you type 36 over 288 into your calculator, it will tell you that that is equal to 1/8. Next, I'm going to look only at the x's. So I'm going in alphabetical order here. I have x to the 4th over x to the 1st. This is a division situation. So in division, I need to subtract my exponent. So I'm going to do 4 minus 1. Means that this is x to the 3rd power. I'm writing that answer in the numerator. Next, I'm going to look at the y's. Y to the 3rd minus -2, right? Subtraction with my exponents, minus -2. So 3 minus -2 is 5. All right, z to the -3rd, z to the 2nd. Well, it's still division, so I'm still subtracting. -3 minus 2 is -5. So I can write z to the -5th. And then I still have that to the 3rd. Now this -5 right here means the z is homesick, right? The whole z needs to move down here. So this is equal to, I'm not going to write the 1. I don't need the 1. X to the 3rd, y to the 5th, over 8z to the 5th, to the third power. All right, so now I'm ready to stamp that 3 onto every single one of these bases, remembering that when I've got parentheses, I need to multiply my exponents. So this becomes x to the 3 times 3 makes 9. Y to the 5 times 3 makes 15 over 8 to the third. Z to the 5 times 3 makes another 15. This is my final answer. Each letter appears once, and I only have positive exponents. All right, press pause. Talk in your group about this problem. Try to answer each other's questions, and then when everyone's ready, let's do number 14. Okay, I think on number 14, the best thing to do is to deal with just the numerator, and then we'll worry about the denominator. So just the numerator is this big, long product. I've got 56 times 32. Well, that seems like a great time to ask your calculator, doesn't it? 56 times 32 is 1,792. I've got a to the second and a to the third. Those are multiplied together. So in my memory trick, if they're multiplied together, I need to add my exponents. So 2 plus 3, that's going to be a to the fifth. B's, b to the third and b to the fourth, is going to make b to the seventh. C to the negative 3 and c to the 3. Well, negative 3 plus 3 is 0. And anything to the 0 power is 1. So that c is gone. It turned into a 1. Okay, so we have that over